this video is mainly for my benefit, but yeah, I'll talk through it just in case I decide to put it up. Now, what we're going to be doing is installing the sensors. So I've got the reference coil and the main sensor coil in what is a new prototype version. And the difference with this one is that it's a 32-bit chip, and it comes with some pros and cons. So, you sort of hear 32-bit, you go, oh yeah, it's got to be better, but that's not necessarily the case. One thing with this chip is that it operates at 3.3 volts instead of 5 volts that the other one does. And with 5 volts, we've got a bigger signal to play with. So we're able to extract the small variations easier from a 5 volt signal, whereas the little signal we're playing with is more likely to get lost in a 3.3 volt signal, particularly with respect to the noise. But there's other factors. So it's a lot faster. The analog to digital converter, there's 2 of them in this instead of just one, and it's higher precision, so fingers crossed that will balance out in the end. But we won't really know until we put it together. Being a faster chip, hopefully if there is a bit more noise, then we might be able to run some aggressive software filtering and have it filtered out that way. But we're not going to know until we get that done. So a couple of things with this. It is set up to test a few things, so I'm going to test replacing the adjustment pots for it. Maybe I can get some more precision there. I've been using, I think, 20k pots, but well, no, 5k actually, I think. But I don't think I need to be that high. I think I can probably get a lot more precision out of going a lot lower one, but I've never actually played with it. But anyway, here we go on our install. Get our solder, and I think probably run out of it doing that. So I'll do the reference coil first. Which one is it? 23.9 or 29? It doesn't. Actually, those is probably both, depending upon the meter that read it. So let's see, put that in. Yeah, noise. Okay, so what we're going to do here, we need to test that it's conducting, and that looks good. So okay, happy with that. Now for the sensor, the main sensor. Now the issue here is the order in which they go and which ones they go through. So, and I've also got to get the length right. Although the length isn't too critical, as long as I've got enough let's see. And I've got the order here. I need to separate them out. Unfortunately, these wires are very, very fine. I don't need that on. So I think, which one's the longest? That one's the longest, that one goes there. And the next, so the two shortest of these two. And then my outputs. So, what we're going to do is and one of the things I did with this new design was make that hole a little bigger, but that might come back to bite me. So I need to work out if that was the longest, yes. So it's now a case feeding it through. Let's double check. That's what we want to hear. So, actually I think I changed this so I went in reducing. Whereas on my thing I've got longest, second longest, and then I swapped it. So no, I think I actually rotated it for all of the more recent ones. Not that it matters. I can put it back to front if I need to, because I've designed this to allow me to correct it if need be. I've just put that in the wrong hole. There we go. Now before I solder it, I'm going to put it back in, because I just want to check I've got enough excess. I'm just checking the depth on that. That looks like it could go forward by quite an amount. So I think what I'll do, actually I'll just do that. That's why I wanted it set down, so I can just push on that. And I think I'm going to have to modify inside there get it a bit more clearance. So it's not going as deep as I like. But I've got the room to do it, so I'm happy with that. So at this point too, just make sure. So we're good there. Now it's just a case of feeding this through a couple of times. And to do that, I'll actually trim it off to get a clean end, because there's some soldered bags on the end of it. And I'll move to the closer glasses. Okay. So just make sure it's still got enough slack around here, because what we do is we install a cap over the top of it when it's actually installed in here to bolt that down and provide some structure to hold it in place. But right now we're back into the soldering. So the noise is on. So here we go, the big test. That's what we wanted to see. I think we can test it there. And well, this is the reference, so that should be there. And then we have here that, so that is in. And that is that. Yeah, some of the things I've had to do with this newer version, just with the change in the hardware, is quite a lot of programming change. Well, the software is entirely different. The environment for developing it's entirely different. And so effectively I had to do it all from scratch. And we do actually have it operating, and it is relatively stable. So I don't know if I can pretend at the moment. What I can do is take the output from the zeroing and pass it into the reading. We'll see what we get, and so that's the zeroing, and it's sitting pretty stable. We've also got the temperature, and the reading on this now can go up to just over 4,000, so 4096, and the old one could only go to 1024, so we've got 4 times the precision in terms of the reading. But the downside of that is that if we had a couple of digits of noise on the old one, I think 14 or 2 or 3 numbers is like 14 millivolts, but 14 millivolts on this transfers to a change of 18, which is a lot. Projectiles are measuring around 9, 8, the good ones are measuring around 8, 9 or 10. So, if we're getting 18 from the noise, then it's a bit of a problem. But this is actually it looks pretty stable. It seems to be quite happy sitting here on that, and it adjusts reasonably quickly. So feeding that back. So that's not too bad, I'd say. That's looking pretty good. I mean, that reading's not wobbling at all, and it's quite responsive. So we do a big change. And given the significant, how big that change was, it's actually settled down pretty quickly. So, yeah, that I'm pretty happy with. So, still working through the software and getting it together, but yeah, we have a new prototype. I made a slight change to the backstop. I wanted a better base for gluing it down and whatnot, and apart from that, it's just exactly the same. The design is a bit different, obviously, because the chip's different. All the components are effectively the same for the rest of it. The voltages are all different because this thing runs at 3.3 volt. One of the other things is, in order to keep the noise down, because I knew that was going to be a big problem, I've had actually been watching some interesting informative videos on noise, and they were mainly related to noise on multi-layer boards like 4, 6, 8 and higher boards for signals operating at high frequencies, and they were calling high frequencies anything from about 100 kilohertz up, and 100 kilohertz is basically the frequency this operates. And what it was saying was that you might have a signal coming out, and you might think that the ground return signal on it's actually going to go the shortest path back, but it doesn't. It actually wants to travel back along the same path. And if the only way it's got to do that is on another one of the signals, say in this instance here, we have our drive signal to our sensor, our coil, but we've also got our zeroing signal here. And if you didn't give it a ground return path, it would choose to come back via this, along this section here. So what I've actually done is, where I've got the signal line coming out, I've actually got a ground line either side of it on this layer. Traditional sort of convention has been, oh, you've got a ground plane on the bottom and it will return along that. But the thing is, that ground plane is actually too far away on what is a 2-layer board. And it will choose to go on the closest one. And so I've had to make sure I've got some good space between the boards, and I've had to make sure that the best thing to do is actually just eliminate the worry and put the ground plane as close as I can to it, running beside it. So the actual, I should be getting a lot less noise because of this than from the other one. So hopefully that'll turn out to be a positive thing. It's already looking quite a bit more stable, so it looks like we're on a winner. So I'm going to get some hot glue and glue this in place, the reference coil, because we don't want that wobbling, or that's going to put our signals out. And actually I'll paint that up with some epoxy to hold it quite steady. It's a bit more stable than the hot glue, and then I'll put the hot glue on top of that. So, because the hot glue's still got some flex in it. And as far as things go, I'm calling this done for this video. So thank you for watching, and I look forward to getting this going. I do have a few boards for it, and I do have a number of completed units of the old design, and it could turn out that the new design doesn't work as well as the old one. It could turn out it works exactly the same, could turn out it's slightly better. Until it's actually together and tested, there's no way to know. So that's why I'm doing it. There's some benefits to this, being able to get it manufactured with the chips and all that sort of stuff on board. just makes it easier. I've got less soldering to do, and I'm getting older and my vision's not so great, so anything that can cut down on close-up work is a good thing. So especially trying to solder small chips and whatnot, and also too having a smaller microcontroller where the other one was quite big. At least this way I'm able to condense all of that further away. I don't, if I've got a bigger chip here, it pushes some of that stuff out closer to all of that analog stuff that's over here. So it's good in that respect to be able to do that. And the other thing is I've got sort of the digital voltage regulators over on this side, and then the voltage regulator for the motor, that's just for driving the motor, and then the analog stuff is these two. So the analog components, the analog to digital converter and whatnot, and the chip are actually highly isolated from the noise of the digital signals. But the closest ones are these ones here, and similar to what I was saying before with the return path here, I've actually got a ground return path for these ones over here driving the display, because that's going to be pretty noisy. So yeah, hopefully we'll get some great improvements. If this thing doesn't turn out to be as good as the others, what I'll do is I'll redo the other board, and I'll incorporate some of these changes and try and get those benefits, presuming that they are benefits. So yeah, thanks for listening.